Hi, I'm Bob. Welcome to the solutions to the textbook Microeconomics Theory and Applications with Calculus, the 5th edition by Professor Jeffrey Perloff. We will continue to solve the problems at the end of Chapter 11, Monopoly and Monopsony. We are addressing the exercises of the monopoly profit maximization. Here is exercise 1.6. The inverse demand curve that a monopoly faces is linear. The firm's cost curve is as follows. What is the firm's profit maximizing quantity and price? How does your answer change if the cost function changes? We can address the problem in 3 steps. In the first step, we find the monopoly's marginal revenue and marginal cost functions. In the second step, we equate the marginal revenue and the marginal cost to solve for the profit maximizing output and price. In the final step, we check whether the answer changes. From the inverse demand function, we can find the revenue and marginal revenue functions. From the cost function, we can find the marginal cost. The monopoly chooses the profit maximizing output Q star, such that the marginal revenue equals the marginal cost at that quantity. We can solve for Q star, which is 47.5. At that quantity, we can find the market price from the inverse demand function, which is 52.5. Finally, we find that the marginal cost function is unchanged for the new cost function. The profit maximizing quantity and price are unchanged, since both marginal revenue and marginal cost functions are the same. Let's find answers to exercise 1.7. The inverse demand curve that a monopoly faces is as follows. We also know the firm's cost curve. What is the profit maximizing quantity and price? It is straightforward to find the answer. We derive the marginal revenue function from the inverse demand and the marginal cost function from the total cost. The monopoly chooses the profit maximizing quantity Q star such that its marginal revenue equals its marginal cost at that quantity. We solve for the Q star. It equals 1. The profit maximizing price is 10 after we plug the Q star into the inverse demand function. Let's solve exercise 1.8. Suppose the inverse demand function for a monopolist's product is as follows. We also know the cost function. Draw marginal revenue and marginal cost curves. At what output does marginal revenue equal marginal cost? What is the profit maximizing output? Check the second order condition at the monopoly optimum. As usual, we find the monopoly's marginal revenue and marginal cost. And then equate the two functions to solve for the monopoly's profit maximizing quantity and price. We obtain a quadratic equation. Using the formula, we find the two roots. Both are positive. we are required to draw the marginal revenue and marginal cost curves. I graph the curves in data. We can see two intersections between the two curves. Which one is the monopoly's profit maximizing solution? We must check the second derivative of the profit function with respect to quantity. It is also called the second-order condition for maximization. If it is negative, then it means the slope of the firm's profit curve decreases. In other words, the firm's profit increases until it reaches its maximum and then decreases. So, we aim to find a negative second derivative of the profit at the firm's profit maximizing output. At Q1 star, the second derivative is negative. So, it is the quantity that the monopoly maximizes its profit. Let's go to exercise 1.9. If a monopoly's inverse demand and cost functions are as follows, what Q star maximizes the monopoly's profit? At Q star, what is the price and the profit? Should the monopoly operate or shut down? From the inverse demand function, we obtain the revenue and marginal revenue. From the cost function, we have the marginal cost. The Q star maximizes the monopoly's profit when marginal revenue equals marginal cost at that quantity. We can solve for Q star. It is 4. At that output, the market price is 9. Then, we can calculate the firm's revenue at the profit maximizing quantity, 36, and the total cost, 37. Notice that the total cost contains two parts, the fixed cost and the variable cost. The firm's profit equals its revenue minus its cost. It is minus 1. Although the profit is negative, the firm should not shut down in the short run because the revenue is greater than the avoidable variable cost. The revenue offsets some of the fixed cost. If it operates, its profit is minus 1. By contrast, if it shuts down, it loses the fixed cost of 25. Therefore, the monopoly is better off operating despite losing money because it loses less than shutting down. In the long run, when all inputs are variable and avoidable, the firm should shut down if it makes a negative profit. Let's find answers to exercise 1.10. Given that a monopoly's marginal revenue curve is strictly downward sloping, use math and a graph to show why a monopoly's revenue curve reaches its maximum at a larger quantity than does its profit curve. We first use the graph method. Suppose the marginal revenue curve is downward sloping. It hits the quantity axis at Q hat. Q hat is the quantity at which the monopoly maximizes its revenue. The marginal revenue curve intersects the marginal cost curve at quantity Q star, where the monopoly maximizes its profit. The graph shows that the Q star must be located to the left of the Q hat. Next, we use the mass method. Suppose the marginal revenue function is P equals A minus B times Q. A and B are positive. It ensures the marginal revenue curve is strictly downward sloping. The firm's revenue is maximized when marginal revenue equals 0. That is, Q hat equals A over B. Suppose the marginal cost function is P equals C plus D times Q. C is positive and D is not negative. It ensures the marginal cost curve is upward sloping or horizontal. The firm's profit is maximized at Q star, where its marginal revenue equals its marginal cost. We can solve for the Q star. It is smaller than Q hat. So the monopoly's revenue is maximized at a larger quantity than the one its profit is maximized. Thank you very much for doing all the exercises with me today. See you tomorrow. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.